Okay, so we're going to verify basic trig identities. Tomorrow or Tuesday, we're going to do the more complex ones. So I'm trying to really walk you into this with baby steps, right? So just 2 examples today, and we're going to get some work time. You'll get to ask questions and stuff, okay? I'm going to start with example 4 in your book because I think it's the easiest one. And then I'm going to skip back to example 1. Okay. So in 7.2. So find a numerical value of one trig function if okay, so in 7.1 we were just looking at expressions. There was no equations. Now we're going to introduce equations into the mix. So if I have that equation, how can I simplify it to one trig function? Much like we did this one here, number 16. Cosine x, yeah. Cotangent over cosine equals 2. Is it easier here?
Yeah.
Wow, I'm impressed. Okay, can I write cotangent as something else? Yeah, it's cosine over sine. That is a problem. I see why you didn't learn anything. Okay. Now what can I do to manipulate that fraction? Yeah. It's fraction division, so I'm going to copy the top, dot, and then flip the bottom. You're going to use that a lot, so get used to it. Yeah, and then you can cancel the cosines, right? And what's that answer? Cosecant. That is it. You've just simplified it to one trig function. Okay. Oh. That does make it difficult to answer. Okay. So you're confused
From the start.
here to here, right? There's a trig identity on, yeah, we did write it down. If you look in your book too, page 422 at the bottom.
1 over 10
It is,
alpha thing.
but it's also cosine over sine.
Why can't you just write simpler like that?
Because it doesn't get you anywhere.
Got it, got it.
So they had a good question, and this is something you're going to have to get through. Okay. Cotangent's 1 over tangent. I can write it in there, correct? Does it get me anywhere? No, there's no simplifying that expression. So if you write something in and it doesn't help you, think of something else to put in there, okay? So did that clear it up a little bit? If it doesn't work, try something different.
Cosine x sine x.
That's cotangent. Cotangent, an identity, is cosine over sine.
Then why is the bottom one 1 over?
It's cosine. You don't need to change it because we're already in terms of cosine.
Oh,
Okay. So I just put it over 1 to make it a fraction, to make it obvious. All right. I think we got past that little trouble. Okay. Okay, verify that secant squared x, I am in the way, minus tan x cotangent x equals tan squared x is an identity. Basically, okay, the right side's easier, correct? Or I should say more simple. I wouldn't say. Okay, so we're going to manipulate the left side to match the right. We're going to change it. Hopefully, eventually, it'll say tan squared x equals tan squared x. Okay. Okay. What can we change on the left? Okay. We might go that direction. You two probably should pay attention. Okay, since we're headed towards tan squared, it's probably not productive to change things into sine and cosine, right? So that's why I kind of stepped away from what you said. We want to get this as an answer. Changing to sine and cosine is probably not going to help. But okay, these two now cancel out, right? Cotangent's 1 over tan. We have a minus 1 there. Is there a way to change secant x into tan x? There's an identity. What is it? Try to find these as we go through that, so I'm giving you time. So the identity, secant squared x equals tan squared x plus 1. That's an identity in your book, the one I gave you. So I'm going to substitute now. You got to think, I'm trying to get to tangent, right? So is there an identity that takes secant to tangent? The answer is yes. It's right here. Okay. So I'm continually trying to change things into tan. Not stupid. Okay, so these cancel out, right? I have the eyes of a hawk and the ears of a fox. Haven't you seen Lord of the Rings? The elves pull their bows and there's an elf right in his face. Good stuff. It's +1 -1 is 0. The tangents cancel out. So you have -1. What one? The +1 comes from the identity. Secant squared is tan squared x +1. So I insert. Okay. Are you okay? You kind of getting it? You substitute. And if it doesn't work, like Anir suggested this is 1 over cosine squared. If it doesn't work, just erase it and try something different. It's trial and error. You don't have to be perfect the first time. Okay. I can't tell you how many pieces of paper I went through in college trying to write proofs for math. Okay. So if it doesn't work, try something different. Do you want me to show you another one or just let you get some work time? That's 3. Okay. I'll have to dig one out of my repertoire. Let's see if I can find one. I'm saving that for Tuesday because it's harder. Yeah. This one's Tuesday because I want to check it. Okay. Otherwise. Okay. Okay. Here's another identity. We're going to verify that they are the same. Yeah, that's a good one. Yeah, secant x minus tangent x equals 1 minus sine x over cosine x. It's the second day of the semester.
I have no motivation.
Good job, Sina.
Uritis. I didn't even bring home.
You are thinking on the right track. So here's the question. Do you want to manipulate the left or the right?
The right.
Okay, I'm hearing right more, so I'll do that first. Okay, how can I, so you can see here, sine over cosine is tangent, right? So is there a way to split that up so that you get sine over cosine? Can I split that fraction up into 2 fractions so I get 2 terms? What are they? 1 over cosine minus sine over cosine. Okay. Common denominator. You're just, instead of putting them together, you're taking them apart. What's 1 over cosine? Secant. And sine over cosine is tangent. And you're done. Okay. You could have done the left side. You know, secant's 1 over cosine, tangent sine over cosine, then combine the fractions, and you would have had the right side. So that one was a little more straightforward. Let me get you started. This is the first part. So we have 9, 13, 14, 29, 40, 46 through 53. I've given you the review for the weekend, so you have more time to do it. Okay? Tuesday's homework will just be 7.2b with no review problems or anything. So, but yeah. So this is due Tuesday because I want to get a check on your understanding, and then we'll do the harder stuff. And then Tuesday, Tuesday I'll give you 4 or 6 problems, and that'll be it. So. Okay, you have 10 minutes, 15 minutes. Good time to ask questions. Let me know if you need any help.